Yeah, good afternoon all. We in India Technologies welcome you all for this webinar on designing for sheet metal fabrication using SolidWorks. We are waiting for a couple of attendees to join, so kindly bear with us for 2 more minutes. Yeah, thank you. Yeah, thank you all for bearing with us for a couple of minutes. So I would like to start the webinar on the same, that is designing sheet metal fabrication using SolidWorks. Let's get started with this. Yeah, so we are the India Technologies. We are the value-added resellers of Dassault system. As a VAR, we provide sales and support for the Dassault system products like SolidWorks, DraftSite, 3D Experience, and etc. And this is a contact address, that is Golden Square, 10th Lane, 4th Block, Janagar. We have the contact number as well as the website here. Like at the end of this webinar, we'll also share the few more contact details to reach us for the inquiries and queries. Yeah, so before getting to this webinar, I'd like to just go ahead with the fully integrated design platform of the SolidWorks in all the fields, like considering the mechanical and the electrical design, preliminary design, design validation, technical communication, as well as the product data management, including the quality and manufacturing. We have the solution for all the divisions. So SolidWorks CAD has the capabilities to Yeah. So SolidWorks CAD platform is available in three formats, like SolidWorks Standard, Professional, and Premium, so that you can leverage with the customizations, the tools availability, and you can have it which were required for the industry. Okay. For the design validation, we have the simulation tools like the simulation, static, structural, non-linear. Even we have the flow simulation, plastics as well. Okay. We have the CAM and SolidWorks MBD. So the SolidWorks MBD is a fourth generation platform for the industries, which can leverage with the 2D draftings, which will completely eliminate the 2D drawings, and it will give you the 3D PDFs, so that you can directly access all the dimensions and the GD&T tolerances and 3D PDFs, and you can rotate the model, you can view all the dimensions. So the shop floor guy can easily understand the dimensions without any issues. So we have the DraftSite, which is the direct competitor for the AutoCAD software, which is available in the yearly subscription format. This tool is perpetual. It is one-time ROI. So only one-time investment is fine for this. So coming to the Composer and Product Data Management, these are the two tools. They are industry leading, and if you're going to deal with the product data management using the SolidWorks PDM, which will help us to like deal with all the higher level management, design, and the other teams as well. So you can make the revisions and you can leverage your data with whole team. Okay. So this is a short description about the overall integrated platform of the SolidWorks. So we have the solution for all the divisions. We don't need to switch for the other tools. Okay. Yeah. So we'll directly jump into the today's webinar concept. So I'll introduce the sheet metal parts. So after that, I'll go through the brief discussions on the SolidWorks sheet metal fabrication design demonstration. Including that, I'll showcase the sheet metal assemblies and drafting capabilities. So you can have the better costings for parts and assemblies. And including this, I'll also showcase the few of the advanced features in sheet metals. And finally, we'll have the closer look on the productivity benefits using SolidWorks. Yeah, so let's get started with the introduction to sheet metal parts. So when it comes to sheet metals, so we need to know what exactly the sheet metals are. So these are the parts which has the uniform thickness throughout the parts, which should have the bends and should be flattened. Okay, and this particular sheet metal component has the industry standard, the thickness range, that is from 0.4 mm to 6 mm thickness. Okay, this range the sheet metal components follow. So for a manufacturing approach, we have the different processes like shearing, folding, splicing, riveting, forming, and punching, cutting as well. So at your right corner, you could see few of the sheet metal components which I had showcased, which are gone through the bending process and other folding and riveting and even the forming process. Okay. And in this particular industry, we have the standard materials which like has been used, like aluminum, which is predominantly used, and brass, copper, steel, as well as the nickel and titanium. Okay. Coming to the nomenclature of the sheet metal components, if you consider, we cannot take the flattened length into account. So why we use the software is to get the total flattened length. So that is very complicated if you're going to deal with the normal traditional method. So if you're considering the sheet metal component which has the bend, so you're gonna consider this as the bend allowance region. Okay. So outside you're gonna deal with the compression, and the inside it has the tension. So when you bend it, the bend allowance gonna takes place. So how we need to calculate this plays very important role. So we'll just go with this particular concept within just a few minutes. Coming to the bend allowance concept, if I take this L bracket into account, we can consider A and B as lengths. So if you want to find out the total flattened length, when you flatten it, it will be A plus B plus bend allowance. So the distance plus bend allowance. Now, how to calculate this? So we have the standard formula for that. Bend allowance, which is equal to A, which is the bend angle, which we're going to consider here. It is 90°, and pi by 180 into bracket R is the inside bend radius. So this is the radius we're going to consider. Okay. And K is the constant. It will vary for each and every materials like steel, aluminum, and all. So it is not exactly at the center, the neutral axis. It will vary depending upon the material properties, that you need to remember. And the T is the total thickness of the material in meters. So whatever the inlet system you're going to consider, that should be same throughout the equations. Okay. So once you solve it, you're going to get this particular flattened length formula, that is A plus B plus bend allowance added. So sometimes we need to consider the bend reduction. So why this is the case? Because if you consider the steel and aluminum and different other materials, due to the material properties, sometimes the flattened length might increase as well as decrease. So if it is increasing, you can add the bend allowance. If it is decreasing, we need to consider the bend reductions. The formula is bend reduction, which is equal to 2 times of R plus G tan of A by 2 minus BA. That is bend allowance. Thus, you're going to get it from the previous formulas. And once you get these data, you can just simply input here. That is, A is the total length. You need to remember it is, and we're going to consider from this edge to the top edge, and B is this length, and minus bend reduction. You're going to get the total flat length for this. Okay. So that's about the like basics of sheet metal works. Okay. Now we'll jump into the fabrication design using sheet metals. So I'm going to consider the model you could see here. This is the satellite receiver box, which has the top cover as well as the bottom cover and the front casing. So this model you could see, we're gonna just design it using the SolidWorks sheet metals. Okay, and you could see there are a few complex features also available. So we'll see how exactly the sheet metal gonna help us to just deal with these things and tackle the issues while dealing with the designs and all, and how it will help us to save the time. Let's get started. Yeah, so this is the satellite receiver assembly, which has the bottom casing and the PCB board. I'm gonna approach with the assembly, top-down assembly approach. So I'll take all the parts into account. So whatever the changes you're gonna do in this model, everything will be updated into all the parts. Okay. And this is the enclosure cover. So you can use the display styles, you can hide and show, so that you can just improve the performance of the model. So I'll edit this part. So I had created for the new sheet metal part creation. Okay, that is enclosure cover. So it is blank. You can feed the new part here. I'll start with the SketchUp workbench. By using this particular SketchUp workbench, okay, so you can just draw the sketch like a normal sketch. Okay, the random sketch initially, and then you can just define the dimensions. By using the SolidWorks constraints and the dimensions, you can be able to do it. Okay, the quick access tool will help us to just define these things within a shorter period of time. Let's say I want the thickness should be maintained as 1 mm, that is offset distance. So which will help me to leverage the sheet metal thickness and the geometric constraints. Okay, and let's say I'll make it horizontal. When you see this particular layer, I need to make the shape. So I'll use this one. You can use the advanced selection tools and convert entities to just take that one into reference, and you can trim it like this. So once you have the shape ready, you can use the sheet metal tools. Okay, the standard set of tools are available. You can simply switch there. You can use the base plunge in the beginning. So in the SolidWorks sheet metal, we have the advanced capabilities. Like you can extend the features up to the vertex and the surfaces. Let's say I want this vertex should be taken into account. Like this, you can extend. Now, the standard sheet metal industries follows the by default gauges like the standards. So for that, you can access them to define the bend radius and the thickness. So these are the few examples like bend allowance in inches, bend allowance in millimeters. We have the K factor and the samples for aluminum and steel industries. So I'll take the industry standard, that is a common steel gauge. So if you do it, you'll have this set of gauges available. So if you start with the lower gauge, it is of 6 gauge to 25. You can see the thickness, it is 3.5 mm. So when I go to the 25 gauge, the thickness will vary to 0.55. So as the gauge increases, thickness will also decrease. I'll take 1 mm thickness and the bend radius as 0.5. And you can keep the bend allowance as default as per the standard sheet which I had taken. Okay. Can include all these things. If you simply click on green check, whatever the data you have fed it, it will be stored as default. Now, this will be the default format. You could see this has some interference here. I need to remove some of the material. So what I'll do is I'll use the sketcher workbench. I'll snap the sketch. Let's say the rectangle one, corner rectangle I'll use. You could see you can snap these points. So this is the advantage of SolidWorks. So you can easily snap all the corners and the midpoints very easily. I'll take the dimension as 15. You can use the tool that is Extruded Cut to remove the certain material. So you can define the dimension. When I click on preview, you could see how easily it has fitted there. So here we go. This is fine. So we are done with that. So I'll also showcase one of the feature, that is the miter flange, which is the very powerful tool. So on this particular edge, I want to propagate the same. So as I'm working with the top-down assembly approach, I can refer, or I can just use these reference points into account to create my design like this. So these are the references. So once you exit the workbench, you can miter it along the corners. So up to the next end, it will automatically extend if you click on this icon, that is propagate. So how easy you can do with this, like this miter conflict shapes are ready. So let's say when it comes to the inputs, there are multiple inputs. You can define the material inside, material outside, depending upon your requirement, right? You can give the opposite distance as well. Let's say it is 0.25. You can increase it to 1.25 and 2.25 like this. If you're looking for the corner gaps, you can maintain here. And the starting offset distance. You could see at this corner, we have given it. And sometimes we need the stress relief regions. So you can use the custom reliefs here. So you could see how easy it has created, and the relief also got added. We'll see edge flange feature now. So again, this is the most powerful tool. I'll use these edges into account. So simply left click will help you to select the multiple edges, a simple one. Again, here also you can define the corner gap if you want to maintain it. And then we have the options like defining the angles and the material inside, material outside, the same thing, and go on. The reliefs, if you want, you can add it. So this is how this tool will help out to create the edge flanges in a simple time of span, like short span of time, you can say. The dimension 12, that is fine. So this feature, I want to mirror it completely so that I can cover whole model. So you can use the mirror tool. This time I'll use the bodies to mirror. So all the features which I have created in one shot should be mirrored. You can simply rotate the model. As a reference, I'll choose this face. So once you do this, here we go. This is what we get, right? So now I want to connect this top cover to the bottom casing cover. So for that, I need some fasteners. So I want to screw here. I will create a edge flange so that I can leverage with this. So I'll showcase one of the advanced feature here. So whatever the edge you could see, it is extended, right? I want to customize it. So for that, we have the edit flange profile. So this tool will help us to leverage with the design. So you can customize your flange design however you want. And this quickness snaps will help us to reduce the time span to define the constraints, right? So hold the control, just release it, use the quick access tools. That's all. So we can come back. So at least has some interference. So what I'll do is I'll just give some of the offset, 1 mm offset, so that it could fit easily, so that I can screw it properly and create the hole there. And here we go. Yeah, this is what you get, and this stress relief region also created. The assembly is ready. So let's say I want to make some changes into the enclosure piece. So I'll change the configuration from default to large. So if I do that, what exactly gonna happen? See, the entire enclosure will change. So this is what the advantage of the SolidWorks assemblies. Okay. So whatever the changes you're gonna do, it is fully integrated. It will change according to your design. So this is one of the robot features in SolidWorks assemblies. Okay. Now I'll work on the top cover. Let's say I want to add some of the grips on this particular cover to hold it properly or strengthen it. I might need to add some hems as well. So let's say I want to add the forming tool. So what you can do is you can access the design library tool, which is available in SolidWorks Professional. You can just simply drag and drop the forming tool. So this is very easy to do it. So you could see the preview, right? You can leverage with the flipping options as well as the positions by just switching to the position, and you can use the smart dimension tool. I have customized my shortcuts like C4 dimension and alpha line D4 trim like this. And you can define the dimensions like it is 25. So once you are done with this, if you just simply click on print check, this is what you get. Very robust one. Within a fraction of seconds, you can create this, right? Yeah. So now I want to strengthen the back face. So for that, I'll use this hem tool. So you could see there are some of the types and sizes are also available. So I want to assign this to all the 4 corners here like this. Yeah, so you can switch to the sizes like open one, closed, and the flat one. So here I prefer the flat hem. You can define the dimension 12. Let me take 15 because it is fine to fit the locking fence there. So I want to lock this to the top cover as well, right? Yeah. So now I will add some of the locking lengths here. So again, you can use the same tool, forming tools, and drag and drop it like this. So let's see, while defining the forming tools, you now define the angle as well as the direction. No, here we can just flip them, and you can even leverage with the rotations as well. Okay, I want to rotate it to 180 degrees. Here we go. For defining the position, switch to the position and activate the dimension tool, and just define the dimension. From this edge to this, you can take up to 10 is fine. Yep. Here we go. Right. So I need few more locking lenses. So instead of creating again, I'll use a tool that is the pattern. So which will save the time, right? Can refer the edge as a reference, go to the features and select the locking lens and define the distance. So I'll take it as 40 and you could see this is the spacing which I'm looking for. Range. Now I want to mirror them so that I can have it on both the sides. So this time I'll showcase the mirror features, not the mirror body. So you can refer the cleans as well by using this drop down. So from here you can access all the features. And here for the features, you can select the pattern and the forming tool. Range. That's all. Yeah, finally, this is how it looks like. Right. So for heat transfer and all, I might need to deal with the validation, right? So I might have the ventilation support as well. So the fill pattern tool will help me to create some of the cutouts like diamond and other shapes. So which will also help me to engage with the heat transfers and all like. Yeah, so here you can define the dimensions for this particular fill pattern. I'll take it as 10 is like big, the length as 12. I'll customize it like this. I'll reduce the spacing. It is fine. This is fine. Now coming to the sizings, you can manage here. 2 is too small, right? I'll manage it to 3. Yeah, fine. Now sometimes you might need to remove some of the dimensions, right? So for that we have the robust tool, that is the instances to skip. This tool will help us to remove the not required dimensions like this cutouts. And once you're done with this, this is how it looks like. Easy, right? Yeah, so again on the top face as well, I want some ventilation to be created. So for that, I'll leverage with the vent tool in the sheet metal. So first I'll drag and drop the sketch which had already created to save the time. Okay. So now again, I want to introduce the SolidWorks, the quick access tools and the snapping advantages. Let's say if you want to fully define this, you can edit the sketch like this, and you can leverage with the quick access tools and hold the controls like these two coincident. Don't need to go somewhere and make the changes. Simple. Once you're done with this, you can exit the workbench, and I'll use the vent tool. So which is again the powerful tool we can say. So in this particular tool, you need to define the boundaries. So I'll take all the 4 corners into account like this, and we can activate the preview. So at the moment, I'll just turn it off. Yep. So I'll define the dimension as 0.5 as the radius, and the thickness you can specify it as 1.5. I'll specify the ribs. So these ribs and the center sketch. So this is all. If I simply click on green check, this is what we get. Yep. So this particular shape, if you want to do it manually, it's gonna take a lot of time, right? So we can say it is best one. We can directly go back to the assembly workbench, and we could see how exactly your assembly looks like. This is what the final assembly is. Right, so this is how we can use the SolidWorks assembly workbench to deal with the sheet metal components, and you can even work on the sheet metal tools on a parts. So yeah, so this is somewhat the brief discussion about this. Now we'll see how exactly the SolidWorks assemblies will help us to deal with the sheet metals. Okay. Now here you could see this is the face bezel. I want to assemble inside this particular sheet metal like a satellite cover, we can say. Let's just so I'll just showcase this for now. So you can just use the SolidWorks assemblies and you can use the insert components. This is the face bezel which I want to insert. So what is the advantage of this is I had included few of the smart features into it. So what exactly it does is it has the few features which will automate my particular assembly. So if you simply click on green check, it will stamp the location where it needs to be fitted, as you could see, like this. So very advantageous tool like the smart features we have. So when I just switch to the face bezel, you could see the lightning symbol. Once you click on it, it'll have this face. It is indicating where you need to assemble it. And according to that, I might need to add this cutouts for these indents, right? So for this, I need to select the face for this positioning. So we have the advanced option that right click on the face and select order will help us to snap the faces and recognize them and again directly select them. Easiest way, right? So in other softwares, it is quite difficult to do this. So once you click on green check, you'll have the final model like this, which has the holes automated inside. So this is how this assembly workbench will help us to leverage our designs. So along with this, we have the advanced mates like the mechanical mates, we have the smart fasteners included, we have the exploded views, animations we can able to create. Okay, the motion study is also there, bill of materials you can able to do it. So even the difference check, clearance check. So even the very robust mate tools like the shortcuts, holding the control and defining the mates and holding the alt and just having the realistic views to deal with the mates and all. So I can say the SolidWorks assembly is the best one. Yep. So now I'll introduce the drafting capabilities of SolidWorks with sheet metals. Yeah. So this is the assembly. I'll take this cover, the enclosure cover. So before getting into the drafting, I would like to add some of the corner treatments, like the fillets or the chamfers at the corners, because while dealing with the laser cutting method, sometimes the corners, if you have the sharp corners, it is very difficult, right, to have that particular shape. So this particular break corner tool will help me to leverage this particular issue. That is, you just simply select the face, the tool will automatically recognize the corners, and you don't need to like invest more time to just select these things. And simply rotate the model and select the remaining faces like this. Yep. So once you're done with this, you can simply go ahead with the preview. Could see this is how it looks like. Fine, right? Yeah. So now what I'll do is I'll create the drafting for this. So you can switch the templates. So instead of using the default template, I'll use the own customized template which I had already created. So which has the advanced like layers and all, so that you can see the preview here. So I'll use the enclosure cover. This view palette, which will activate only while working on the drawing. So which is very advanced. You can use all the standard views and drag and drop it like this. Yep, you could see this is the flattened view, which has all the annotations and the bend angles and the bend lines, the bounding box. If you want, you can include. We have the like the lawyers and the forming tools already included. If you want to like exclude them, you can directly go to the document settings and you can turn it off. Okay. So if you want to give it for the laser cutting operation, you need to convert this into a DXF format. You can do it by using the save as option. That is also one way. Or else I'll showcase few more methods. Okay. So in this SolidWorks drawings also, we have the most robust tools that we can use it. So that we can discuss later. Yeah. So now we will see about SolidWorks vehicles, how we can use them to give the realistic views to the assemblies as well as the components. Along with this, we'll see the constants for parts as well as assemblies of sheet metals. Yeah, when it comes to this model, let's say I want to add some decal here so that I can see how exactly it's going to look like in normal. So we can activate the photo view 360 from the add-ins. So in this tool, we have the edit decal. So from this tool, you can convert all the JPG and images like IGS format images into the decals like this. So I want to place it. So you can switch to the mapping once you browse it. Just select the face you want to place it like this. So you can adjust the spacing, you can drag it, or you can use the fit to width selection or fit to height selection. So that is also one of the powerful tool to fit it normally. So once you are done with this, this is how it looks like. So exactly the realistic view, and the customer can understand what and where exactly we need to place. So when it comes to manufacturing, isn't it? Yep. So this is about the decals. When it comes to the costings, I'll work on the assemblies. So this is the assembly. Let me just deal with the part first. Costings for the sheet metal parts. So the costing is activated. You can use it from the evaluate tool. So this is it here. The template editing I'll showcase later. Let's say I'm using the steel material and the name is plain carbon steel. The material cost is 3.35 USD, and I'm using the total number of parts here as 100, so I'll use it as 25. The lot is same. Okay. So once you're done with this, you can simply just give the software to just deal with the begin estimation, that is cost estimation. So it will give you the value. So it is 42.62. So these are the things which we need to define, that is adding the forming tools and the vents. So for that operation, you can define the costings. So I'll just quickly do it. Yeah. So once you do it, you could see the costing here. It is $79.12, right? So like this, you can have it even, you can generate the reference PDFs. Let me just change the material and see. If I change the material to aluminum, you could say it is 80. It got increased. So like this, you can estimate the cost for parts. When it comes to assemblies, it is the same thing. So let me just showcase the template editing here. Let's say this is the template in general. I'm using the USD, so you can even customize it to INR. We have the standard formats for that. If you want, you can download it. The operations, each and everything is customizable. The operation cost and all, we can enter it manually according to the requirement. If you want to edit it in a better manner, you can open the templates of Excel and you can edit it according to the costings exactly which you prefer in your industry. So the templates for INR are also available. If you want, you can just request us. We can even share it and we can even customize it from the Resolve system as well. Okay. These are the few fillet beads, and according to the costings are available. Okay. Can leverage these things by the manual edit here. That is about the template. So I'm considering the whole sheet metal assembly. So PCB is I had suppressed, which I don't want. So I'll just simply click on begin cost estimation for this. Need to be calculated here. Yep. So you could see it is 56.80 for per assembly. So if I change the lot to 1, it will increase to. Can click on update. So it will show it is 66.70 like this. So bulk it is less, and for single assemblies it will increase. Like these are the few details. So if you want the report for this, we can use the report tool and it will generate the report and you can use it. And if you want to customize it, it is customizable because it's a Word format, fully editable. And this is how we're going to help us. So again, we can say the SOLIDWORKS costing is this one. So we can take the help of this to deal with your particular steps. Okay. Yep. So I'll showcase the DXF to DWG conversions as well. So if you're going to deal with the manufacturing of these things, you need to cut your entire sheet metal parts, right? So for that, we need the DXF formats or DWG formats to fit into the laser cutting machines. How to leverage with this? See, this is the model. How complex it is, right? By just looking at it, we can feel like it is very complex to design. But the powerful tool, the miter tool, had helped me a lot to just design within just few seconds only. Okay, let me just take the flattened view of this so that I can just create the DXF format. So if you just simply click on flatten, you'll get the export to DXF to DWG. So this tool will help me to just customize it one and all. You're looking for bounding box or forming tool. If you want to include, you can do it, but I'll take it as default geometry. Okay, so this is the DWG format. Now you can save it in the form of DWG as well as JPG. But remember, before saving, the scale should be 1:1. Okay, that you need to take into mind. Yeah, so this is about converting the SolidWorks files, sheet metal components into the DXF or DWG format. Yeah, so this is what the final model is. Now, I would like to showcase a few of the advanced features in sheet metals. Let's get started with this. Yep, so this is the model which I had created by using the SolidWorks part design method like this, using the revolve feature, boss extrude, mirrors, and adding the holes, mirrors, and the chamfers at the corners. Now, if you want to convert this into sheet metals, you just need to use the insert bends tool. So within a fraction of a second, you can do it. You just need to select the flat face and you need to give the bend radius because the uniform thickness anyway it is available. You don't need to define it. Okay. Once you do that, you can easily convert this into sheet metal components. So you can easily flatten it like this. Right? Yep. So I'll showcase a few of the examples again. Let me just switch to another model. Yeah, this is the one, watertight miter flange. But just looking at this part, you could see how complex it is, right? So when it comes to the design part, it is quite difficult. But by using this miter flange tool, it is like it made me very easy to design it. So initially, I had drawn this base flange, and you could see this is the sketch. A simple sketch helped me to create this watertight mesh. So I have one more example for the same thing. Yeah, this is the one. See, this kind of complex shapes you can create it by using this robust tool. And the sketch is this. A simple sketch made me to create this. Or if you consider other tools like other softwares, it is very difficult to deal with this kind of approach. Yeah, so let me just showcase this one. It has some intersect region, right? I need to create a jog feature. So for this, we have the pre-made tool jog. So before that, I'll sketch a line on this. So I'll refer this edge. You can use the offset tool. Let's say 5 mm, right? Yeah. So now by just referring this edge, I could able to create the jog feature. Let me just showcase the same. Here, just select this line. You need to define the fixed face. This. Here you can just leverage the jog offset. I'll take it at 2.01. Thickness of the sheet metal is 2.01 is the clearance. And here we go. So within a short span of time, we could able to create it. But when it comes to solid edge and all, it will take a lot of time to design this. This is the flat length. And yeah, so let me just showcase last model, this one. So I would like to showcase the cut feature here. Like if you use this extruded cut, activating the normal to cut feature. So I'll use it to all. And when I do that, to flatten it, it would shape. So according to the laser cutting, it has already created this feature. So what exactly I wanted to showcase here is, so if you don't use this normal cut feature, let's say this one. Let me just showcase a preview. I'll use the flatten view here. See, this is what the face you're gonna get. So this is very difficult to cut, right? And this kind of operations is not at all possible. It is possible, but it is very time consuming and it is not recommended. To avoid this kind of things, we have this tool that is normal to cut, which will help us to leverage this kind of issues while designing the sheet metal components, right? You could see you have the perfect corners. Yeah, so these are the few models which I had considered to showcase so that you can have the better understanding on the sheet metal advanced features. I'd like to showcase one more robust tool that is convert to sheet metal. We have two ways to convert the sheet metal. It's like if you're using the step files or the universal CAD files, any formats, what you can do is, one, you can simply give the rip and the bends. One more is you can use the convert to sheet metal tool. I'll showcase both here. Yeah, so this is the step 5. Let me just first break the links. You need to remember the feature works will help you out to deal with this. So once you break the link, you can just use the diagnostic to repair your faulty faces in one shot. So SolidWorks will take care of your all the faulty faces. Okay. So once you're done with that, you can add the rip gaps at the corners. Let's see, just one and this corner. You can define the gap. So once you define this, we have the simple tool that is insert bends. So in this, you just need to define the face, that is fixed face, and the bend radius. That's all. The thickness is anyway uniform everywhere here. Auto reliefs will be created automatically. So this is what we get. So we could say this is the flattened view for this. Quite easy, right? Now one more way is to deal with the convert to sheet metal tool. So you have the solid body. Now you need to convert this to sheet metals. So here you need to select the fixed face again. Define the values, or you can use the gauges as per the industry standards. Let me just take 1 mm as thickness and 0.5 mm as the bend radius. So here you select the bend edges. So this one and this one. So you could see automatically the rip edge got created, right? So you don't need to worry about it. So software will take care of this corners. Now If I simply click on green check, you would see this straight away. Sometimes you might need to customize your rib caps. So you could see the sketch, right? The center sketch. I want the rib cap there. So in this cases, we can use this option, that is the rib sketches, to leverage this particular points needed. So you can simply add the band, this one. Here we go. Quite easy, right? Yeah. So this is about the convert to shape metals. I hope you got this. And this is the final flattened view, which we now get. Well, yes, so I'll switch to the productivity benefits using SolidWorks. So how exactly gonna help us or give the benefits if I use a SolidWorks? So everyone has the questions, right? Even the competitors who are using other tools, they will also ask the same questions. What are the benefits? Yeah, so this is the ROI investigation. So from the previous customers which we had discussion, so from there we had gone and we had approached for the reviews. So these are the percentage of the respondents for the reporting. So when it comes to the faster design iterations, it is on an average of 69% when it compared to the previous design methods, traditional methods they were using. The design with the fewer errors, it is 67%, and the reduced time spent on the average ECO, that is 61%. Faster time to market by just avoiding this revisions and dealing with the design changes and all. So it is 54%. That is reduced volume of ECO. So this is the engineering change order. It is the document which will help us to check the proposed changes to the existing products. So it got reduced around 37% by using the SolidWorks tool. Okay, so this is about the a few respondent reports. So I hope this will help you to just deal with your requirements. Yeah. So finally, when it comes to the fully integrated solutions, so if you are looking for any solutions from our side or any support or any consultancies, anything, it might be the training, it might be the just support or any queries as well, you can come back to us. So with respect to the CAD, with respect to the simulation, CAM, Composer, 3D experience, graph site, anything it is. So you can directly approach us anytime. So we are always available for you guys. So finally, to summarize, so we have gone through the introduction to sheet metal parts. So dealing with the demonstration on the sheet metal fabrication design. So leveraging with the assemblies and the sheet metal draftings, considering the costings as well, and the advanced features in sheet metals and convert to sheet metals. Finally, the productivity benefits. Yeah. So who are the attendees here? They have the special offer from our side, so they will get the free consultation. So they can directly contact us anytime to if they are facing any issues or the queries with respect to SolidWorks. They can directly contact us if they are looking for the trainings or if they want some of the solutions from our side. We're always there. Okay, anytime you can approach us. So the contact details I'll showcase. So this is the person, the assistant manager sales, the Udit Khatiyal, who is going to help you out with this particular queries. So please get in touch with Udit Khatiyal for the same thing. You can find the mail ID and mobile number, so you can just save it right away. So if you have any questions to be asked, you can directly mail to this Udit Khatiyal so that he can revert you and will also reply to your all the kinds of queries on sheet metals behalf of this webinar. Yeah, so I would like to wind up the webinar. Thank you for attending and giving the precise time to just coming to the webinar and attending it and making this webinar successful. Thank you all, guys.